Hi everyone, my name is Quran Mahmood Bhatti and I am a Technical Success Manager in Datum Security Services. I am also Vice President Trainings at Code Movement Pakistan. I have around 15 years of experience and my major skills are open source technologies. I am an Agile practitioner and a Scrum Master. Following are my contact details. If you wish to contact me, you can shoot me an email or you can contact me on Skype. So, the topic of our today's presentation is the code standards and styles, in which we will talk about some best practices regarding code standards. In this presentation, we will be discussing the following principles and approaches. These are separation of concerns, try principle, which is do not repeat yourself, solid principle, version control system, and we will talk about some considerations along with development. The following slide outlines a list of best practices and preferred styles when writing code for apps and website development. All code should be self-documenting. This means strict typing where possible, as well as descriptive functions and variable names. Doc blocks and inline comments must be added when it is possible to describe with the code alone. And also remember one thing, so long as it compiles, a computer can understand it. The purpose of writing clear code is for other humans to read, comprehend, and maintain it. The program in picture 1 is used to find the sum of two given numbers. So the output is 3.5. Now we are going to add type declaration to our function arguments. Now you will get the output as 3. Why? PHP automatically changes the type of input arguments to int data type. This is called the coercive mode. We can enable strict mode on a per file basis. To enable strict typing, the declare statement is used with the strict types declaration. In strict mode, only a value corresponding exactly to the type declaration will be accepted. Otherwise, a type error will be thrown that you can see in the picture 3 in red color. Now we understand the basics of type declaration with coercive and strict modes. In this slide, we will talk about descriptive functions and the name variables. The preferable naming convention is the verbose function name, as it makes the call site more readable. Of course, some function names can get really long. The rule of thumb is that any function that contains AND in the name has too many responsibilities and needs to be split up into separate functions. In the following example, we have a method to obtain a position in a Fibonacci series. Without considering name conventions, we use a function name getIt with other variable names x, a, b, and I. From readability point of view, these names do not make any sense to the reader. However, the example on the right side has a proper function name getNth Fibonacci and other variable names such as search pose, which is actually the search position, previous number, current number, and index. These functions and variable names make more sense for a meaningful code. Now, we will be discussing about the best practices in writing comments. There are three main reasons for writing comments in your code, which is communication, very important, clarity, and explanation. A bad comment is worse than no comment at all. Writing and then maintaining comments is an expense. Your compiler doesn't check your comments, so there is no way to determine that comments are correct. You are, on the other hand, guaranteed that the computer is doing exactly what your code is telling it. While all these points are true, it would be a mistake to go to the other extreme and never write comments. Here are some rules to help you achieve a happy medium. So if we talk about the rule number 1, which is comments should not duplicate the code, many junior programmers write too many comments because they are trained to do so by their introductory instructors. I have been students in upper degree and computer science classes add a comment to each close phrase to indicate what block is ending. As you can see in the picture, comments that add no information have negative value because they add visual clutter, take time to write and read, and can become out of date. According to rule number 2, good comments do not excuse unclear code. Another misuse of comments is to provide information that should have been in the code. Simple example is when someone names a variable with a single letter and then adds a comment describing its purpose. If we check in the example, so we have a variable name node n in this second line of picture 1. However, it can be best replaced by the name best nodes, which you can see in the picture 2, which has more sense. If we talk about rule number 3, if you can't write a clear comment, there may be a problem with the code, which is very much self-explanatory. And rule number 4 states that comments should dispel confusion, not cause it. Rule number 5 states that explain an idiomatic code in comments. If we go into detail of rule number 5, it's a good idea to comment code that someone else might consider unneeded or redundant. Without the comment, someone might simplify the code or view it as a mysterious, essential incantation. Save future readers time and anxiety by writing down why the code is needed. I recommend not including comments for common idioms unless writing a tutorial specifically for novice. So, rule number 6 states that provide links to the original source of copied code. If you are like most programmers, you sometimes use code that you find online. Including a reference to the source enables future readers to get the full context, such as what problem was being solved, who provided the code, why the solution is recommended, what commenters thought of it, whether it still works, how it can be improved. As per rule number 7, include links to external references where they will be most helpful. Links to standards and other documentation can help readers understand the problem your code is solving. While this information may be somewhere in a design document, a well-placed comment gives readers the pointer when and where it is most needed. Our rule number 8 states that add comments when fixing bugs. Comments should be added not just when initially writing code, but also when modifying it, especially fixing bugs. The last rule, but not the least one, is the use comments to mark incomplete implementations. I hope the above examples have shown comments don't excuse or fix bad code. They complement good code by providing a different type of information. Alright. So this picture shows how separation of concerns works. This picture shows an MVC pattern that shows different modules. These modules are exactly what separation of concern is. In an MVC pattern, controller talks to model as well as view. Model also connect to the database, which helps in getting the required information. If all of this code is inside one module, essentially a single file, then it makes it very difficult to update a specific module. So ideally, breaking down a bigger module into smaller modules and each module performs a specific function can help us in making any changes. So our next topic is the DRY principle, which is very important in software development. DRY stands for do not repeat yourself, and it is one of the primary principles of good, clean code used by every professional programmer daily. Very naive explanation of this rule says that you should not just copy and paste the code around, and that is true. But it's about much more than that. Keeping your code dry is about application of knowledge and intent. When we write our programs, we codify the rules that govern the business side of the program, and this process is very costly. Time of programmers is very expensive, and throughout the lifetime of a product, a single change gets the attention of very many people. There is another aspect, like there are authors, reviewers, and the programmer who finds the bug in the code and fixes it. And then there is someone who builds on top of the code and extends it. In the given picture, we have a Python code, and on the left side shows a repetition of header, footer, and menu code, which is an unnecessary repetition. And for a single change in any code block, one has to change in every code segment. That is, home page and about page segments. However, by applying drying principle, code is much cleaner and making any changes is easier, which you can see on the picture on the right. Right. Now, we will discuss solid principles in detail. So, the first principle is the single responsibility principle. The principle of single responsibility says that each class should be responsible for one specific thing. There should be only one reason to modify the class. First of all, because many different teams can work on the same project and edit the same class for different reasons. This could lead to incompatible modules. Very logical. Secondly, it makes version control easier. For example, say we have a persistent class that handles database operations and we see a change in that file in the GitHub commits. By following the single responsibility principle, we will know that it is related to storage or database related stuff. Merge conflicts are another example. They appear when different teams change the same file. But if the single responsibility principle is followed, fewer conflicts will appear. Our second principle is the open-close principle. So, by definition, objects or entities should be open for extension but closed for modification. This means that a class should be extendable without modifying the class itself. Let's imagine that your software entity is a class shipment. Your project manager asks you to change the behavior of the shipment in your descriptive application. Should you modify the class? Absolutely not. Your class should be closed to modification. We don't have the right to change it, but how can we ease the wrath of our project manager? Obviously, we need to extend our class. Our third principle is the Liskov substitution principle. Objects of a superclass should be replaceable with objects of its subclasses without breaking the application. Let's have some real-life examples. Your father wanted to fix the main gate. Okay, so your father wanted you to fix the main gate light bulb, but you gave him disco vibes instead. He won't be happy. In the second example, you fed your neighbor's pet duck spied bread, and now it's dead. You decided to replace it with a toy duck. He won't be happy either. Our next principle is the interface segregation principle. So by definition, client should never be forced to implement an interface that it does not use. Or clients shouldn't be forced to depend on methods they do not use. In the given code, any shape you create must implement the volume method. But you know that squares are flat shapes and they do not have volumes. So this interface would force the square class to implement a method that it has no use of. This would violate the interface segregation principle. Instead, you could create another interface called three-dimensional shape interface that has the volume contract, and three-dimensional shapes can implement this interface. Last but not the least principle under solid principle umbrella is dependency inversion principle. So based on this idea, high-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. Does that picture shows dependency inversion? No, it doesn't mean that dependencies should be inverted. The principle states that there should be no direct link between your low-level and high-level modules. Think about a car. What if a steering wheel was connected directly to a car wheel? Every time you would change a wheel, some adjustments to the steering wheel would be required. Now we know this would be a bad design. So we have an interface between them that takes care of communication so they don't have a direct link. Alright. Now we will be talking about the version control system. So by definition, version control, also known as secure control or source control, is the practice of tracking and managing changes to software code. All repositories use Git and are hosted on either GitHub or CodeCommit. So first of all, we will talk about the repository naming. Some examples are listed here. You can see on the slide. Repository contains the source code of a site. Name should be the main naked domain name of that site. It should be lowercase. As we know, we have branches in the version control system. So once a project has gone live, the master or main branch must always be stable. It should be safe to deploy the master branch to production all times. All branches are assumed to be active. Stalled branches should get cleaned up accordingly. Now we will talk about the PRs. We call it pull requests and we also call it merge requests. Pull requests help to add a check layer in the workflow. In order to merge code to be deployed to staging or production, a pull request must be created and submitted for review. All code must be reviewed by the project's lead developer. So now we will talk about the included file. So if we talk about inclusion of files, only source files should be included in a Git repository. Dependencies, user uploaded assets, IDE configurations, log files, cache and similar files should be omitted. Those files could be added to a .ignore file and is by no means meant to be exhaustive. So in the last, for the version control system topic, we have commits. Commits must be granular and descriptive commit messages are required. A commit message with less than 3 words is likely an indication that the message is not descriptive, while a message longer than 10 words may indicate that commits are not granular enough. Okay. Now, we will talk about some considerations that we should keep in our mind while doing development. There is no rule of thumb for selection of technology stack for your application development. There are multiple factors which helps one in deciding the technology stack. For example, many prefer to use content management systems such as WordPress and Drupal for rapid development, since several community plugins and modules help in building applications rapidly. For custom solutions, it is preferable to use frameworks, since it gives the flexibility to implement business logic. And if the application needs extensibility, then it is wise to use a technology which can help developers extend the application in future. So if we talk about the security and dependency management, then dependencies should be avoided when possible. When inclusion of a package is needed, it should be thoroughly vetted for security vulnerabilities and to ensure that it is currently maintained. It is always advisable to check the stability of modules and plugins, consult with senior team members to include any package in any project. Packages should be kept up to date to ensure that the latest patches are included. By any means, we cannot compromise our application just because of some external libraries. So, the last topic for our presentation are the time estimation techniques. Time estimation is critical in software development. Therefore, multiple techniques can be used to get more accurate estimates. The first one is the use of historical data. Examining similar projects that were completed recently by the company can help. However, this should never be the sole basis of establishing your future estimates. Remember, every project is unique and the differences between them thoroughly affect their completion time. Second technique is the analogous estimation. Instead of using previous projects as your basis to estimate software development time, you may research existing cases and make adjustments to account for the differences. For example, you might use the time required to complete a project with a similar scope or the time required to complete a project using a similar technology. Our third technique is bottom-up estimation. This approach involves spending an ample amount of time in brainstorming every specific task involved in the whole development process and estimating the time required to deliver each milestone. As you can see, this method can be very effective when used properly. However, it can also be time consuming. Now we will talk about top-down estimation. In contrast, the top-down approach estimates the total time required for the project first before breaking that estimate down into smaller chunks. Our fifth technique is the parametric estimation. The parametric estimation involves using statistical methods to accurately predict the time required for software engineering. This estimation process requires software developers to utilize data points from other parallel projects in the past to come up with the right time estimates for your ongoing projects now. Our sixth technique is 3-point estimation, which is quite interesting. A 3-point estimation uses 3 estimates for each task: an optimistic estimate, a pessimistic estimate, and a most likely estimate. The final estimate is then calculated by taking the average out of 3 estimates utilized. Last but not the least is the function point analysis. Function point analysis involves making an estimate for the whole project based on the functionality of the software. In similar terms, the more features it has, then the longer it takes to build it. So that's it for now, and thank you very much for watching this presentation. If you have any question, you can reach out to me. I will be happy to answer it. Thanks again. Bye for now.